Hey everybody, Mr. Troy here. I want to explain the point of this video. There is a worksheet for you on Google Classroom. I want you to try that factoring worksheet as best you can. The answers are also posted. And then come back and I've got a video explanation for you about how it works. It's a good way to check your understanding. It's a good way to see if, oh boy, I didn't know how to do that thing I thought I knew how to do. Okay? Then, when you're ready to come back, it's time for math with Mr. Troy. All right, here we go. All right, when you start a factoring problem, the first thing you're going to look for is the sign on the constant term. You want to know if it's a plus or if it is a minus. If that sign is a plus, that means the lasts multiply to make a positive. So it either has to be something like x plus and x plus to make both of the lasts positive, or perhaps like in problem number 4, m minus and m minus. Here, my lasts would have to multiply to make positive 35. In this case, it's going to be negative 5 times negative 7. Okay, so the first thing you do is you look for the signs. If we've got a negative constant term, then we're going to have our lasts be one positive and one negative. So for example, for problem 3, we're going to have r plus for one positive last and r minus for one negative last. Now, there's one nice thing that we can know or remember, and that's if we see all plus signs, our problem's going to have all plus signs. All right, so first step, look for the signs. Then, you're going to start by looking at the factors that you can use to multiply to make that constant term. So what numbers could multiply to make that last? Well, sometimes those numbers are going to pop out to you. Sometimes you're going to see 90 and you're just going to say to yourself, I wonder if it's 9 and 10. When you're able to do that, that's called building intuition, and that's great. So when you're able to do that, then you do a little bit of check. This is all guess and check and intuition and getting better and practicing. So if I plug in like this, my inners and my outers, 10x, 9x, that would add up to make 19x. That tells me that this is right. Final answer. Last time I'm going to say it today, remember that these two answers are the same. Doesn't matter if you say x plus 9 and x plus 10, or x plus 10 and x plus 9. Now, maybe it doesn't pop directly into your head. And in that case, you have to say to yourself, okay, what are the factors of my constant term? So I could multiply by doing 1 times 18, or 2 times 9, or 3 times 6. Notice how I went in order 1, 2, 3. Now, which of those that multiply to 18 add to 9? Well, 3 and 6. So x plus 3, x plus 6. For problem 3, it's a little bit more complicated because the things that multiply to make 21 are 1 and 21 and 3 and 7. But if I'm trying to think about it being negative 21, that's really 1 and negative 21, or negative 1 and positive 21. So twice as many options. 3 and negative 7, or negative 3 and 7. Out of all of these options, which add to make 4? Well, positive 7 and negative 3. So it'd be r plus 7 and r minus 3. A lot of times we're going to use small numbers. So 35, 1 and 35, 5 and 7. Now, which of those make 12? Well, negative 5 and negative 7. M minus 5 and minus 7. That's our first 4 problems in just over 5 minutes. Not bad at all. Oh, hey look, we're on the next slide. All right, here's what I want you to do. I want you to pause the video, and I want you to go through on each one of these problems and say how I knew that this is the setup for each of these. How did I know 5 was x plus something, x plus something? How did I know 6 was x minus something, a minus something? How did I know 8 was n plus something, n minus something? All right, pause, take a look. All right, here's the deal. When our constant term is a plus, that means the signs have to be the same. So either plus plus or minus minus. On this one, they both have to be negative because I'm adding up to make negative 16. All right, moving on. This problem is not possible. Oh no, why would you do that to us? Well, sometimes that happens in life. The only things that multiply to make 15 are 1 and 15 or 3 and 5. None of those add up to make 5. No dice. All right, next problem. To make 64, I got all sorts of stuff. I've got 1 and 64, 2 and 32, 4 and 16, 8 and 8. Now, when I look at those, I see 8 and 8, and I say, oh, 8 and 8 make 16. So I've got a minus 8 and a minus 8. This was our perfect square trinomial from last week. Another way to write this is a minus 8 twice. Problem 7 is called a difference of two squares. Now, you could memorize that just because you see that there's no middle term, or you could think about it like this. P squared plus no p's minus 4. Well, what multiplies to make negative 4? 1 and 4, maybe 1 and negative 4, or 2 and negative 2. Well, plus 2 minus 2 would have the outsides and the insides cancel out. All right, problem 8. I've got 1 and 7. Well, maybe negative 1 and positive 7, or positive 1 and negative 7. That's the only way to multiply to make negative 7. Now to add to make negative 6, the one of those that works is plus 1 minus 7. All right. So here are the answers for 9 through 12. One thing that I want to stress is that if you have already written out the factors of 24, don't feel like you need to write them out again. Okay? So if you do this problem and you get your x minus 3 and your x minus 8, when you go on to problem 11, you could say, well, is there some way that instead of just doing subtraction, doing negative 3 and negative 8, could I do positive 6 and negative 4? Sometimes the answer will just pop into your head. So when I see 32, the first thing I think of is 4 and 8. When I see 4 and 8, I go, oh, hey, that adds to 12. Must be the right answer. And for problem number 10, here are my possibilities. None of those work. When none of them work, it means it doesn't factor. All right, one thing to notice between problem 13 on this page and problem 9 on the previous page. Problem 9 was x squared minus 11x plus 24. Problem 13 was x squared plus 11x plus 24. One had minus 11x, one had plus 11x. So in that case, the signs just switch. It becomes plus 3 plus 8. All right, 14, 15, 16, whole different kettle of fish. The first thing you want to do is you want to take out the common factor. To be frank, most of the time on these problems, that's just going to be the leading coefficient. So on 14, it's 3. On 15, it's 4. On 16, it's 3. Then you want to try and factor those parentheses that are left. So I'm looking at 63 and I'm saying, ooh, 63. Well, 1 and 63, and well, it's not even, so it's not divisible by 2. 3 and 21. And I'm looking at them like, man, those numbers aren't that familiar. Is there one that's maybe more familiar? So skip over a bit. What if I do 7 times 9? Oh, those are 2 apart. 2 apart. So I could do 3 times a minus 9 times a plus 7. We've done one like this already, so it would be 4 times a plus 8 times a minus 3. And this would be 3 times p minus 1 times p minus 1. And sometimes we write that as 3 times p minus 1 squared. All right. I hope this is going okay for you. I hope when you're looking at this, you're like, I think I know how to do that. I got to weigh in on doing this. But make sure you practice and make sure you ask questions. All right. See ya.